Hello everyone, thank you so much for viewing this video. Before we get started with discussing the contents of the video, I wanted to introduce my nonprofit, the Accelerated Training Program. Our vision is twofold. First, we want to expose all marginalized groups to cybersecurity education, as well as removing the systemic exclusion of cybersecurity education to marginalized groups. Our website is www.t-atp.org. And if you would like to partner or want to learn more, please visit our contact page where you can fill out your name, your email, and a message, and we will get back to you. And again, thank you so much for viewing the contents of this video. Please check out the nonprofit when you have a moment, and let's get to the video. Hello, and welcome to day 16, SQL, SQL injections, the king, the carolers sing, and we're still in secure coding. So, set to have all their apps secure, the elves turn towards the one Santa uses to manage the present deliveries for Christmas. Elf McSkitty asks Elf Exploit and Elf Admin to assist in clearing the application from SQL injections. When presented with the app's code, both elves looked a bit shocked, as none of them knew how to make sense of any of it, let alone fix it. We used to have an Elfman code, but he founded a startup and helps us know more, said Admin. After a bit of talk, it was decided. The elves returned carrying a pointy hat and appointed you as the new Elfman code. Congratulations on your promotion. Yay! So we're coding. Okay. So let's start the machine because we're going to need that. Okay, and while that's waiting, I am going to start the attack box. Okay, so we'll keep reading. Okay, as this is getting set up. Okay, so we started our machine and we started the attack box. Okay, SQL refresher. SQL, or structured query language, is the traditional language used to ask databases for information. When you build any application that relies on a database, the app will need to create SQL sentences on the fly and send them to the database engine to retrieve the required information for your app to work. Luckily for you, SQL was built with simplicity in mind, and its syntax is supposed to resemble straightforward English sentences to make it easier for programmers to understand. But before explaining the SQL syntax, let's talk about the specific database engine used on our app, MySQL. MySQL stores information in structures called tables. Think of them as any table in a spreadsheet document where you have columns and rows. For clarity, let's check one of the tables in use in the current application where the toys are stored. Okay, so in the red, this is a column and a column name, and we see the type of toys: a train, an airplane, a car, a teddy bear, animal farm, robot, potato, and rubber ducky. And the blue is a row. And the blue is a row. So we have 4 as the ID, and this corresponds to the teddy bear, a description of a stuffed animal and your new best friend. We have 7, and the minimum score is 8. As you can see, each row of the table corresponds to a different toy, and each row corresponds to a different toy, and each column is a field of data that describes the toy. Looking at the third row, we can see that our toys table contains a toy named Car, and that there are 12 units available for it. Pretty easy. As mentioned before, when an app needs to retrieve information from the database, it will need to build a SQL query. Queries are simple instructions that ask for specific data in a structured way that the database can understand. To query information, we will use select statements indicating which row of which table we want to retrieve. If we want to get all of the columns from toys in our database, we could use the following statement. Select star, so that says select everything from the table toys. And that will return everything. So notice the asterisk, which indicates that you want to retrieve all columns from the table. If you need to ask for specific columns, you can replace the asterisk with a comma separated list of columns. For example, to retrieve only the name and quantity columns, you can issue the following. Select name and quantity from toys, and that will return the name and quantity columns. All table rows are returned in both cases before, but you can filter those if needed using a where clause. Suppose you want to filter the results of the last query so that you only get the toys for which there is at least a quantity of 20. You can do so with the following statement. Select name quantity from toys where quantity is greater than or equal to 20. So the name and quantity are the columns. And then we have the where clause, and that lets us know, okay, we want a quantity greater than or equal to 20. In real-world apps, you are likely to find more complex queries in some cases, but what we've covered so far should be enough for the rest of the room. Sending SQL queries from PHP. Now that we understand how a SQL statement works, let's see how a PHP application builds and sends such a query to MySQL. Although we are focusing on PHP and MySQL, the same idea generally applies to other programming languages. The first step is always to get a connection to the database from our code. To do so, PHP includes the MySQL and extension, which provides the following. MySQL connection, and this is a function. The function receives the IP or name of the database server as a first parameter, so server, followed by the user, and password. And finally, the name of the schema to use, which is just an identifier of the database to which we are connecting. As a result, the function returns a connection handler, which can be used to send further SQL queries. Think of the connection handler as a variable that holds the connection information to the database, so that queries can be sent to it. So we have a server of DB, and remember, this can be an IP or the database server. Our user is logistics user, our password is SUMPASS123, and our schema is logistics. And we're passing all of that in to the MySQL connect function. Once the connection is made, we can issue SQL queries using the MySQL query function. The first parameter we pass to the function is the connection handler we got before, so in this case it's DB. And the second parameter is a string with our SQL query. So here we are selecting all columns from user where ID equals 1. So that theoretically should return one user. As a result of executing the query, we obtain an SQL result set and store it in the elves rs, or result set, variable in our example. A result set is nothing more than the object that contains the results of our query, which can be used in the rest of our program to access the resulting data. As you can see, it is all as easy as building a string with our query and sending it to the database. Okay, so now we're about to get into some interesting things. If we check Santa's web app, we can access an elf's profile by using this URL. So let's go here. Okay, so this is Elf's profile. So this is Elf McSkitty. Depending on the number you put in on the ID parameter of the URL, you get served the profile of a different elf. Behind the curtains, this works by creating an SQL query that embeds the ID parameter value and returns the information on the corresponding elf. So select star from users where ID equals, and that's the missing piece. So right now we have an ID of 1, but we can change that to 2, 3, or however many rows are in that table. So the code will look like this. Select star from users, we're ID, and then we have this, get ID. What is this? And then we pass that query into the MySQL query and it returns a result set. The first line builds an SQL query by concatenating the getID variable as part of the where clause. Note that in PHP, you can access any parameter in the URL as get name of parameter. So here, this ID is a parameter. So in the background, it will be get ID, which is what we see here. Okay. This query will ask the database for all columns of the table users that correspond to the ELF with a specific ID. The second line sends the query and returns the information of one particular ELF as a result set that we store in the ELF's result set variable. The rest of the website then parses the result set and renders the page accordingly. If you test the website, you can see that it works as expected. You have, however, introduced an SQL injection vulnerability in your code that could allow an attacker to dump your whole database. Let's see. We'll get there. And I think I have a way of doing it. Okay. So SQL injection. The problem with the method shown before is that it takes untrusted input. Remember from yesterday's lab, we never trust input ever, like never ever. So we take untrusted input from the user and we concatenate it to an SQL query without asking any questions. As seen in the previous day's task, our app should thoroughly validate any input the user sends before using it. If it doesn't, unexpected things may happen. In the case of SQL, in our example, an attacker can send SQL syntax through one of the various parameters of the app's URLs, which might end up being concatenated to some SQL query and code, potentially changing its intended purpose. Let's get back to the ELF's profile page to understand this better. Remember, the app is creating a query by concatenating whatever is sent in the ID parameter as part of the where clause. So here. So, if the attacker sends the following, we're going to open. When PHP concatenates -1 or ID equal 4 to our SQL statement, it will end up with this query here, where ID equals -1 or ID equals 4. Suddenly, the attacker has injected some SQL syntax that, when concatenated to our original query, ends up serving the data of the ELF with ID equals 4 for some weird reason. If we read the resulting query string, we can see that our where clause was modified to filter only on the ELFs that either have ID -1 or ID equals 4. Since the ID values used by the database are likely all positive numbers, no ELF will match ID -1. Therefore, the database will only return the ELF with ID equals 4. With this example shows a harmless injection, a skilled attacker can try to get to your server to run much more complex SQL queries and potentially force the database to return any data on any table they want. Just as an example, look at what happens when you put the following in the ID parameter. Okay, so let's open. So this returns ELF4. This returns, oh, look at this. It looks like it returns all of the users and their password. Okay. The SQL injected will make the database return all the users and passwords of the application. Yes. Santa won't like this for sure. If you are interested in learning more about SQL injection from an attacker's perspective, you can check the SQL injection room, which is here. For the rest of this task, however, we will focus on the defensive side and look at ways to prevent SQL injections in our code. So don't worry too much if the above URL looks hard to understand. Okay. Fixing the app with ELF exploit and ELF admin. Armed with all this knowledge, we are ready to fix the app. You'll have access to a simple editor to modify the app's secure code during this task. Any change you make in the editor will go live instantly as long as you save your changes by any changes you make in the editor will go live instantly as long as you save your changes by pressing Ctrl S. If you are using the VPN connection, you can access the code editor from any browser of your preference. If you are using the attack box, instead, Firefox is installed and available on the machine's desktop. To get in the code editor, point your browser to the following address. So let's go here. Okay. And to enter the code editor, we're going to use the username and password of coder. Okay, and we're here. Oh, this is so cool. Okay. In addition to the code editor, you will have access to a chat to communicate with ELF exploit and ELF admin. While they don't speak too much, you can request them to check the application for you. If you remember correctly, they don't know a thing about coding. However, ELF exploit will help you identify parts of the app that are vulnerable to SQL injection. ELF admin, on the other hand, will check that the application is running as expected. So if you make a change that breaks the application somehow, he will let you know so that you can roll back and try again. In combination, they will tell you if your changes solve vulnerabilities while avoiding altering how the app is supposed to work. To ask the elves to do a recheck of the app, scroll down the elf chat to find the run checks button. So is it here? Okay, so it's here. Run checks. Remember that you can always check the website after any changes by visiting here. Okay, so let's open that. Okay. So let's move this. Okay. I want to move this closer. Okay. Now let's get to work. One of the easiest and most effective ways to prevent SQL injections is to ensure that any data that the user can manipulate that you are concatenating as part of an SQL statement is actually from the type you expect. Let's go to our ELF chat and click the Run Check button. Okay. ELF exploit should tell you that he successfully injected some SQL via the ID parameter of elf.php. Yes, that's right here. It's in red. Let's open this file in our code editor and look at lines 4 and 5. So let's open that. Oh, darn. Okay, so it's here. Okay. The website takes the ID parameter from the URL and concatenates it into a SQL query as shown above. We can reasonably assume that the website expects an integer to be sent. To avoid injections, we can convert whatever the user inputs in the ID parameter to an integer. For this purpose, we will be using the int_val function. This function will take a string and try to convert it into an integer. If no valid integer is found on the string, it will return 0, which is also an integer. To clarify this, let's look at some examples and how they will be converted. So entering the string 123 will turn into 123. Doing try hack me will turn into 0. 123 try hack me will turn into 123. So putting this to use, we can modify line 4 of elf.php to look like this. So let me add here int val. Okay. That way, even if the attacker sends an SQL injection payload via the ID parameter, the app will try to convert it to an integer before concatenating as part of the SQL statement. In the worst case scenario, the string gets converted to a 0, which is still harmless in this particular case. So let's save our changes. And it says it's saved. Okay. And ask the elf to do a recheck. Okay. And this time, elf exploit will again tell you he can inject SQL code, but in a different way. This happens because the ID parameter is used twice in elf.php to form two separate SQL queries. One to get the elf's information and another to get any toys built by them. Find where this happens and fix the vulnerability. Once you do, ask the elves to recheck, and if your fix is correct, you'll get the first flag. Okay, so let's go here. So here it is here. Okay, so we changed it here. So try hack me, midcode, elf midcode. Okay, so that was the first one. Okay. Now, okay. Now, we're in prepare statements. While in some cases you may secure your code with a simple validator, there are situations where you need to allow the user to pass arbitrary strings through a parameter. One example of this can be seen in the search bar of our application. Every time a search is done, it gets sent to a search toys.php via the queue parameter. So that's here. If you ask the elves to recheck the application right now, elf exploit should have a way to take advantage of a vulnerability in that parameter. Okay, so let's do a recheck. Okay, yes, search toys. So yes, so let's go to search toys. So we're going to close this. Okay, so we see here, okay, we need to do a prepare statement. Here, the queue parameter gets concatenated twice, here and there. Notice that in both cases, the data in queue is wrapped around single quotes, which is how you represent a string in SQL. The problem with having PHP build a query is that the database has no other option but to trust what is being given. If an attacker somehow injects SQL, PHP will blindly concatenate the injected payload into the query string, and the database will execute it. So here. So let's just say select star from toys. So select all the columns from the toys table. Where name like. So you're looking for a string. When you say like, you're looking for a string. And in this case, we're looking for a string that has car. So for instance, if we had a string that was red car, that will come up. We're just looking for a string that has car in it. And the name and description column. Okay. While there are a couple of ways to go about this, the safest bet is to use prepare statements to prevent SQL injections. Okay, what is a prepare statement? This allows you to separate the syntax of your SQL sentence from the actual parameters used on your where clause. Instead of building a single string by concatenation, you will first describe the structure of your SQL query and use placeholders to indicate the position of your query's parameters. You would then bind the parameters to the prepare statement in a separate function call. So, you see here, as before, we had the string car. But in this case, we don't know what the values we're going to pass in. It could be a string, it could be a number. You're leaving it open. And instead of saying car, we have these question marks. Right. Instead of providing a single SQL query string, we We will send any dynamic parameters separately from the query itself, allowing the database to stick the pieces together securely without depending on PHP or us, the programmer. Let's see how this looks in the code. First, we will modify our initial query by replacing any parameter with a placeholder indicating with a question mark. This will tell the database we want to run a query that takes two parameters as inputs. The query will then be passed to the MySQL prepare function instead of our usual MySQL query. The MySQL prepare will not return the query yet, but will indicate to the database to prepare the query with the given syntax. This function will return a prepare statement. So here are our placeholders, and this will bind the values we want to put in. To execute our query, MySQL needs to know the value to put on each placeholder. We defined before. We can use the MySQL statement bind param function to attach variables to each placeholder. This function requires you to send the following function parameters. The first parameter should be a reference to the prepare statement. So in this case, it's called statement. This is the variable, and that has our prepare statement to which to bind the variables. The second parameter is a string composed of one letter per placeholder to be bound, where letters indicate each variable's data type. Since we want to pass two strings, we put SS in the second parameter, where each S represents a string typed variable. You can also use the letters I for integers or D for floats. You can check the full list here in PHP documentation. After that, you will need to pass the variables themselves. You must add as many variables as placeholders defined with every question mark or bind parameter in your query, which in our case are 2. Notice that in our example, both parameters have the same content, but in other cases, it might not be so, meaning both of those, we have the S's, but that might not be the case. The resulting code for this will be as follows. So Q, and we say get Q, and then we do the binding. Once we have created a statement and bound the required parameters, we will execute the prepare statement using MySQL statement execute, which receives the statement as its only parameter here. Finally, when a statement has been executed, we can retrieve the corresponding result set using the MySQL statement getResult function, passing the statement as the only parameter. We'll assign the result set to the toys result set variable as in the original code. So this is how it should look. Okay. So here, so we're going to change this to okay, so want to remove that. So here, this is the parameter, the Q parameter, what we're searching for. And next, we're going to set our query. Okay, so first, let's set this to Q. Okay, so then this is select star from toys where name, like, and are, or description like, and again, these question marks are the values we're going to bind. Okay. So let's see, I'm going to copy this, and then I'm going to explain it. Okay. Okay. So first, this is the search value. And again, this get means we're getting it from the website. And then we're going to make a prepare statement. So we're selecting all columns from toys where name, like, are bound variable 1 or description like bound variable 2. And then our statement is we're doing a prepared statement of DB and then query. Okay. I feel like something is missing, but we'll see. Okay. Next, we do the binding of our parameters here, and we're saying we're going to make it a string, and we're going to use the value Q, which again is here, and that's the value that the user is going to pass in. Then we're going to execute our prepare statement, and then we're going to get the result set, and we're going to store it in Toys R Us. Okay. Okay. So this is flag 2. Okay. There are still some SQL vulnerabilities to be fixed in the code. So now it is up to us. So let's go back. Okay. It says I can inject SQL to force the database in returning Evan Knoll as one of the receivers of an animal farm, even if Evan didn't get enough. Good boy scored to get that present. Okay, so that is toy. Okay. You'll see that Evan isn't one of the receivers. So I will change this here. I'm gonna add that. And instead of, we don't need, okay, so I'm gonna remove this. Okay, so I'm gonna say I, and I'm gonna say, because this isn't, okay, because this isn't a string. Okay, and then we're gonna say select star from toys where ID equals that. And this is our bound. And then I'm going to say there's only one in this case, and that's I. And it's not going to be, I want to say for integers. Okay. I And we're going to do this. I'm going to comment this out. Let's see if that fixes it. Okay, so that wasn't correct. Okay, so let me save. Let me run. Okay. Okay, let me. Yo, is this gonna open? Okay. Okay. Okay, so it's here. So, okay. So I'm going to have my stuff here. I'm going to change this to I. I'm going to change this to ID. Okay. Okay, I'm going to name this kids. Okay. Okay. So that looks like it fixed that. So now, and we're still in toy. By ejecting some SQL, I was able to make the DB return the number 337 as the first toy name. Okay, so we're back focusing on room 16. SQL injections, the king, the carolers thing. So we're trying to find flags 3 and 4. And last time we changed this query into a parameterized query for the deliveries. Now we're still in the toys, and we realize that by entering an ID of 99999 and adding a union all, we're adding 31337 as the first toy's name. So the toys is this query right here. So what I'm going to do is I'm going to copy this and I'm going to paste and I'm going to comment out this and I'm going to change this to ID. And we're going to say select star from toys where ID is this ID here. So what we're going to do now, we're preparing the statement of the database and the query. So this is our query, select star from toys, where ID, and then this is our parameterized value. And we're binding that. So MySQL, so we're binding, and what we're saying is this is an integer, and we're going to bind it to the ID variable, which is the get parameter here. We're going to execute the statement. So we're going to execute the query, and then we're going to get the result. So we're going to change this to toys and save it and execute. Okay, so we found flag 3. Are we secure yet? So I don't know what I was doing the last time. I must have been fat fingering something. Okay. So now let's go to login. And it seems like we can bypass the login with entering a username, adding any username, or 1 = 1. So just to talk about this a little bit, 1 = 1 is a tautology in mathematics. That is the name. It's always true. So it's a tautology. 1 = 1. The sky can be red. 1 = run. The ground could be falling. 1 = 1. It's a tautology. So when you have this here, this payload or 1 = 1, what happens is, let's just say we don't have a blank username. But since we have this or statement, which means either or needs to be true, so this is not true, but 1 = 1, that's always true. So this is going to evaluate the true, and these two hyphens are a comment, so this X is not even executed. So we can enter a blank username, but having this or 1 = 1 will make this true, and it would allow us to log in. So I wanted to explain that a little bit. Okay, so I'm going to copy because I'm being lazy. Well, I'm copying because I find that sometimes I fat finger things, and we don't want to do that. Okay. So, but you see here, we have a post as opposed to these are gets, but we're going to treat it the same because this username and password is user defined input. So what we're going to do here is we're going to say select star from users. Where username equals, so that's the first bound, and password equals, and that's the second bound. So what we're going to do, we're going to comment these out, because that's the old query. And so we're going to change this to strings, because a username and password could be alphanumeric. So we're going to say username, password, because we have two parameters. We have a username and a password. So this username corresponds to this bound parameter. This password corresponds to this bound parameter. And then we're going to change this to users. Okay. I want to run. Okay. So this is the last flag. Okay, so really we didn't need the attack box because we're using the other browser to make it bigger. So if we want more SQL injection in our life, we can check out this room. And I'm going to explain this just a little bit. So in the beginning, we used the int val, and that was to turn all of the parameters into numbers. So for instance, if we had the string, turn all strings into numbers, excuse me. So if we had a string of 1, 2, 3, the ID will be 1, 2, 3. If we had a string of ABC, the ID will be 0. So we did that at first. Next, with the search, we had so we were looking for a substring. So then this is where we start using parameterized queries. And our Q was the like here. And we had two bound parameters for name and description. And so we pass that in there as strings, and we pass Q twice because in our original query, it was this string. So that's why we passed it twice. We executed the query, and then we got the result set. For toys, what we did was we changed the query for the planned deliveries here. So I named it I, but you would want to make it more descriptive. And it was this ID here, this get ID, which is a parameter sent from the application. Then we constructed our query, select star from kids, where assigned toy equals in this bound parameter. So we prepared our query. And then we passed in an integer because we're assuming the ID is an integer. We execute the query, and then we get the result set. So that was part 1 of flag 3. Part 2 was we noticed that 31337 was being passed as the toy name. So then here we changed this query, and I named it ID, which corresponds to this GET request, and we're getting the ID. We're constructing the query, select star from toys where ID equals this bound parameter. We're preparing the statement of the database in the query, which is here. We're binding our parameter. So this bound parameter is going to be ID, and we're passing it as an integer because, again, we're treating the integers, the IDs as integers. We're going to execute our parameterized statement, and we get our result set. Now, you may notice we didn't touch this query, and you may be wondering why. Well, we parameterized this query, and this query, the second query, is coming from our result set of our first query. So since our first query is parameterized, that means we didn't need to actually parameterize this query because the results that are being passed in are parameterized. So I wanted to describe that a little bit because you might be wondering, hey, why did we not touch this query? And that's because you see on line 9, we created our result set, our toys result set. And you'll see here on line 21, we're fetching the toys result set, which is our parameterized result set from query 1, and we're saving that in toy. So since this is parameterized, and whatever we fetch from this is going to be parameterized, so our parameterized results are going to be saved in toy. And then we're accessing that in this query here. We're saying, hey, get from the toy result set, get the creator ID. So that's why we didn't need to touch the second query because we parameterized this query, the toys query, and the second query is using that result set. Wanted to explain that because I tried to change this in the beginning and I didn't need to. Again, this is very important. Need to read how code is written and need to see the moving parts of code, right? Because you might be working on something like I did that you didn't need to work on. Okay. Next, our final was the flag 4. And it was trying to trip us up a little bit because we had gets here, and this is post, but it's pretty much the same thing because the username and password is user input, and we should never, ever, ever in any circumstance trust user input. So essentially what we did here, we had our username and password. We created our query, select star from users, where username is bound and password is bound. So we're creating our query. Then we're binding our parameters. And again, we're using strings because username and passwords are strings. They're not integers. And you'll notice here that we have 2 different variables. The first bound parameter is username. The second bound parameter is password. This is different from in the search toys where we had Q twice. And that was because it was using the same string in our login. That was not the case. We have two separate parameters, username and password, two separate variables, username and password. So that's what we passed. We executed the statement and we got the result set. And we solved it. So that was fun. Again, web is life. And yeah, it will show you, this room shows you how a little bit can go a long way, right? So doing these parameterized queries will allow us to, for the most part, eliminate or remediate 70 to 80% of SQL injections. Of course, you might have outliers, but doing parameterized queries is a great way to mitigate against most known SQL injection attacks. So I hope you learned something in this video, and I will see you in the next one. Have a good day. Bye.